then this transaction branch would share a common prefix to the root. The number 5 step is count of the item set is incremented as it occur in the transaction. Both the common node and new node count is increased by first as are created as n like according to transaction. Now the number 6 point step is mine the created FP tree. For this, the lowest node is examined first along with the link of the lowest node. The lowest node represent the frequent pattern length. Now number 7 step is construct a conditional FP tree which is formed by the count of item set in the path. The item sets meaning the threshold support are considered in the conditional FP tree. The last one step is frequent pattern are generated from the conditional FP tree. Thank you.
Okay. I guess from the MSCIT, Sachin, Ditiman, and Shubham Dev are left. Sachin, Sachin. Hello. I can see Sachin in the chat. Sachin, please respond. Okay. Then we will be starting with in MSCIT, integrated MSCIT. Abdul has already given. You may.
Sachin, sorry, sorry, Raju. If Sachin can hear you, please respond.
So he's not responding from that time.
Okay, okay, continue.
Okay, we will be starting with then integrated MSCIT. The Yumit. Okay, rather than calling, I guess those who are prepared just come up by their, voluntarily. I will be noting down their names. Just come who are prepared.
Good morning, everyone. My name is Jyoti Bora, and I'm from 9SEM. So just wait, I'll be sharing my slide. Raju, is my slide visible?
Yes, it is.
Okay, so today's discussion topic is about FP growth algorithm. So it is an efficient and scalable method for mining the complete set of frequent patterns by pattern fragment growth using an extended tree-like structure to store compressed and crucial information. And this tree is referred as frequent pattern tree. So there is two-step approach. Firstly, in step one, FP tree construction is done, and in step two, frequent item set generation is done. So for that, there are generally two passes. So in pass one, it scans the data and finds support of each item and remove the items that are infrequent. And after that, sorting of frequent items in decreasing order based on their support. And in pass 2, FP Growth reads one transaction at a time and maps it to the path. A fixed order is used, so paths can overlap when transactions share items between them. So here is an example. So here is a transaction data set containing the transaction ID and items. So in transaction ID 1, we can see items like A and B. So in the right side in the diagram, we can see that it's starting from null, that is the root node. From null, it's going to A, and A here is given 1 as it has occurred one time in transaction ID 1. So after that, it has gone to B. In transaction ID 2, there are items like B, C, D. So lastly, we stopped in B 1 in transaction ID 1. So from there, it has started to B, and again it has gone to C and D, as shown in transaction ID 2. So after reading transaction ID 3, it is done in the same way as done in 2 and so on. Actually, only this part was understood by B, so I included only this slide in my presentation. So I'll have to refer to it more clearly. So the advantages. Just wait a minute. So the advantage is that only two passes over data set, and no candidate is generated, and and there is also a compressed data set. So it just helps to save the space. And the disadvantage is that FPT may not fit in memory because it contains a large structure and is also expensive to build. So that's it. Thank you.
Uh, Good morning, everyone. My name is Kashyapi Das, and now I'm going to present on the topic FP growth algorithm. So, wait, let me share my screen. Uh, Raju, is my screen visible?
Yes, it is.
Yeah, okay. Yeah, so first of all, let's go for the introduction. What is FP growth algorithm? So, FP growth algorithm stands for frequent pattern growth algorithm. So before we go for the FP growth algorithm, at first we have to know about a prior algorithm. So a prior is an algorithm for frequent pattern mining that focuses on generating item sets and discovering the most frequent item set. So it greatly reduces the size of the item set in the database. However, a prior has its own shortcomings as well. So uh, now let's go for now let's learn about the frequent pattern growth algorithm. So this algorithm is an improvement to the a priori method. A frequent pattern is generated without the need for candidate generation. The second one is that FP growth algorithm represents the database in the form of a tree called a frequent pattern tree or FP tree. So the steps involved in frequent pattern growth algorithm are: first, scan the database. So in this first step, scan the database to find the occurrences of the item sets in the database. So the second one is construct FP3. So in this, the root is represented by null. The next step is to scan the database again and examine the transactions. Examine the first transaction and find out the item set in it. The item set with the maximum count is taken at the top. The next item set with lower count, and so on. Then the fourth is the next transaction in the database is examined. The items set are ordered in descending order of count. If any item set of this transaction is already present in another branch, for example, in first transaction, then this transaction branch would share a common prefix to the root. This means that the common item set is linked to the new node of another item set in this transaction. So in the fifth step, also the count of the item set is incremented as it occurs in the transactions. Both the common node and new node count is increased by 1 as they are created and linked according to transactions. The next step is to mine the created FP3. For this, the lowest node is examined first along with the links of the lowest nodes. Then the seventh one is construct a conditional FP3, which is formed by a count of item sets in the path. Frequent patterns are generated from the candidate. Conditional FP3 is the last step. So thank you.
Morning, sir. Morning, sir. Hello. Hello.
Yes, you are audible. Yes.
Uh, okay. Today my topic is on frequent pattern growth algorithm. Now, I myself Fayaz Kochar, and I want to say what is FP growth algorithm. What is FP growth? FP growth is an algorithm for discovering frequent item sets in transaction database. It was proposed by Han et al. 2000. FP growth is a very fast and memory efficient algorithm. It uses a special internal structure called an FP tree. FP growth algorithm. What is the input of the FP growth algorithm? The input of FP growth algorithm is a transaction database and a threshold name means up a value between 0 and 100%. A transaction database is a set of transactions. Each transaction is a set of items. For example, consider the following database. It contains 5 transactions, that is T1, T2, T3 till T5, and 5 items, that is 1, 2, 3 till 5. For example, the first transaction represents the set of item 1, 3 and 4. This database is provided as the file context pasquare99.txt in the SPMF distribution. What is the input of the epigrowth algorithm? It is important to note that an item is not allowed to appear twice in the same transaction, and the items are assumed to be sorted by lexicographical order in a transaction. You can see it in the sort, that is transaction ID, items T1 134, T2 235, T3 1235, T4 25, as that T5 1235. Output item set 1 support 3 2 4 3 4 5 4 1 2 2 1 3 3 1 5 2. Now I want to share some advantages and disadvantages regarding FP growth algorithm. Advantages: faster than a priori algorithm, no candidate generations, only 2 passes of a dataset. And disadvantages are FP3 may not fit in memory, FP3 is expensive to build. Thank you.
Morning everyone. Today I'll discuss about the FP algorithm. FP algorithm is a that is based on an improvement over the a priori method. So it represents database in the FP tree. The main advantage of frequent pattern algorithm is that it doesn't take into account the candidate generation. So it allows frequent item set discovery without candidate item set generation. And so it has over there are two step approach is there. First step is to build a compact data structure called a FP tree that is built using two passes over the dataset. The step two is that it extracts frequent item sets directly from the FP tree. Now, what is an FP tree? So it's a tree like a structure that's made up of initial item sets of the database. Purpose of the FP tree. The purpose of the FP tree is to mine the most frequent of the FP tree represents an item of the item set. So mainly there are two passes. Pass one is scan data and find support for each item, discard frequent infrequent items, and the third point in the pass one is that sort frequent items in decreasing order based on their support. In the pass two, FP growth reads one transaction at a time and maps it to a path. Fixed order is used so paths can overlap when transactions share items. Pointers are maintained between nodes containing the same item represented by dotted lines. So this is an example of frequent pattern growth. So we take here a list of transaction IDs and a list of items, and we take a minimum frequency. That means how much the number of items we have to choose. So in the first step, we what we means arrange them in descending order and then draw the node like this. So this is the FP tree where the topmost node represents null, and we draw some path like this, and this all. So I will continue to the direct advantages and disadvantages of FP growth. Now advantages is that only two passes over dataset and compresses the dataset second. And the third point is that no candidate generation and it's much faster than a priori. And the disadvantage is that FP tree may not fit in memory and FP tree is expensive to build. That's all.
Hello. I will start my presentation now. Raju, is it visible?
Yes, it is.
Okay. I will directly go with the FP tree structure, how actually the FP tree is being made. First of all, we have some transaction ID and items. Every transaction have an item list, like you can see BA, BCD, CDEA, and all. Then we have a minimum support count. You will come to know why this minimum support count is being used. We have set it to 2. So our minimum support count is 2. Then what we have to do is that find all the unique items from this particular list. So as you can see, we have A, B, C, D, E, only A, B, C, D, E, and how many times they are being used? Like A is being used 8 times, B is being used 7, 6, 5, 3. That's how they are being used, and we have also arranged them in a bigger to smaller way, like assembly. Now in next. We will rearrange the item list in a proper way. Like first we will arrange the first one like it's BA, then we will arrange in AB, then BCD, ACD, ADE in a proper manner. Okay. I will not use this item list. I will going to be using the arranged manner, the proper one for my tree construction. So this one will be excluded. Now as you can see, in my first transaction, what we have is A and B. In this pattern, FP pattern tree, we have a null node at the root node. Then we have the tree structure with the items list. So first we have A coming one time, then B coming one time. Okay, the first one. Then we have second BCD. So we will again create a tree structure BCD here. See, it's a BCD. Simple. Now you can see in my next transaction I have ACDE. In my third transaction, after transaction 2, we have a ACDE. But here you will come to know that I will not going to create a new tree for this, because A already is being connected to the root node. So I can use this A in this place, then create a new tree from the A part, CDE. Okay, C A C D E. But you can see my A count is being increased to 2 because A came 2 times. So it shows that I have a new tree structure directly connected to the root node from A C D E. It's not very hard to understand. It's like that if you have a directly connected node with the root node, then you can use it to again create a new tree. So ACDE. As you can see, again I have ADE, so I will going to use this same one. This is the root A D E C A D E A D E. But my A count is being increased to 3 because A came 3 times. You can see 1 2 3. Okay, and all are 1 since none of them came twice till now. Now again you see ABC. Again I have a root, a node directly connected to the first one, then again ABC. But here you can see I have a BC coming previous in my previous transaction, and I have a ABC. So I can use this to again create a new one. Then see A B C. C is being connected to the same node. The previous one, if I will show you, see that AB is there, AB is there, AB. So I will use the same one, ABC, A, B, C. I will just connect C here because I have already a node three nodes connecting to A, B. Then again I will use a C. See A, B, C. But here I will increase the count. A 4 times, B 2 times, and C coming first time here in this tree. Then next we have ABCD. Since you all came to know that I am using the same nodes, then you can see I can use the same node here, A, B, C, D. Here see A, B, C, D. Here A count will be increased to 5, B to 3, C to 2, and there is one node D. You see A, B, C, D. Simple. I will use the same things. If you see a similar pattern anywhere, you can use it again. Now again A, then again increase the count of A to 8, just 8. No node will be increased because there is a single A only. See, nothing is increased, only this one is increased to 6. Then I have again ABC. See, I have again ABC. If you see, there is a similar pattern A, B, C. So you come to know that this count will be increased. A will be increased to 7, B will be increased to 4, C will be increased to 3. See, A, B, C. Simply use the same patterns again. You can create the item list again. Then we have ABD. So if you see, there is a in my previous one, you see there is no ABD. There is AD, AC, but there is no ABD, but there is AB. So I will use this tree, A to 8, B to 5, and there is one more D connected. So I will get ABD. See A, B, D, A to 8, B to 5, D to 1. Now I have one BCE. So if there is any node connected to BC, yes, there is a B. Okay, and there is a C also. So I will use this one directly connected BCE. I will use B, C, and one node connecting here E. So B2, C2, E1. C, B2, C2, E1. Okay, so I completed my 10 transaction. I think you all are very comfortable with this now, how this tree is being created. So next I will going to create the FP item set. As you can see, there is a relation between all the trees, B to B5, B to B5. See this relation. See C to C1. I created this connection here. D1, 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 D1. There is a connection. E, E, E connection. Now, since we have this ending, now I will create the frequent item set for every item in this list, for every single item. So first I will start with E. Since ending with E, ending with an E means which one of the tree is ending with E, which one of the node is ending it with E. I have A, B, C, D, A, D, E. Of course there is A, D, E. So I will use this A, D, E, then A, C, D, E. This one will be used. Then we have B, C, D, and B, C, E. So this one will be used. Okay, now see first one, A, C, D. Since A, C, D, E, so E is not needed, only A, C, D. How many times it came? One, only one. A, C, D, one time. Then I have A, D. Since C, A, D, E, A, D, E. So A, D, one time, only one time. Then which one? B, C. So BC, only one time, BC. Okay, we don't need to use A because we already know that E is ending with this. I think oh, okay, there's some issue with my network, sorry. Then now I'm going to find count of each item in the path. Means how many times this particular items came in this particular path. Since ACD in AD, BC, how many times A came, C came, D came. A came two times because in ACD and AD, see A two times came. So A count is 2. How many times B came? B only came one time, only one. How many times C came? C two times, 2. Now how many times D came? D 1, 2, 2 times. So this is my count list of the each item. So A 2 times, B 1 times, C 2 times, D 2 times. Now you know in my first slide, I think I have shown you this minimum support count too. So this will I am going to use to now exclude the items from this particular frequent item list. See, so whoever is less than 2 will be excluded. So we will be excluded. I have only remaining A, C, D. Now I will find the candidate items with them like AC, AD, this one like AE. So which one came with AE? So A relation with AE. How many times AE came? ACD, this AE one time, AE, in this ADE, AE came one time, okay, one you can add. Then BCE, so how many times B came with E? BE one time. Then again, okay, wait, I will go with single one only. AE came over two times, so we will count AE with this relation. So ADE, so AE one time. Again, ACDE, so AE second time. But here in the last one, so I have included ACD, ADE, and BCE. In this, there is no AE. So AE only two times. A came with E only two times in this in both the paths ADE and ACDE. So A only came with E two times in this both path. Next, C with E. So in the first one ADE there is no C, but in ACDE C came with E one time. Okay, and in the next one BCE C came with E two times. So only two times CE. Now next D. D came with E first time, D came with E second time, but in third time there is no D with it. So D count is also only 2. Now we will go with three items. ACE, how many times ACE came? ADE, no AC. ACE, there is one. Okay, one. We will add one. But here also there is no ACE, so it's only ACE came only one time. Next we have ADE with ADE. ADE. So this one will be with added with AE, and there is ACDE. So ADE. See, there are two times. So two. But here only BCE. So there is no ADE. So only two count. Now next we have CDE. How many times CDE came? CDE one. But here there is no CD. So CD count is also 1. And E already came 1, 2, 3 times. So E is already 3. So you can see CD1, ACE1, so they will be excluded because our minimum support count is 2. And only we will use AE2, CE2, DE2 and AD2. So they are only being here. And which are greater than 2 will be included. As you can see in D also we have the similar pattern. We will use here only, we will use a similar pattern and exclude which are coming only one time. So it's very simple to create this frequent item list. So this is my ending frequent item list. Here only A came 8 times, for B only AB and B7. Here C for C6. This one is my item list. So this is my final frequent item list. This is how we create a frequent item list pattern list. Okay. For E we have A, C, D, A, D, E. For D we have A, D, B, D, C, D, and this is all. So thank you. I will end my presentation here.
Okay, I think Vivek is raising hand. Okay, Vivek, you can start. Voice is cracking.
Hello.
Now it's clear.
Okay, so Let's quickly get started. The topic is algorithm. The content will be the algorithm itself. And so, what is FE-growth algorithm? It is basically the improvement of the a priori method.
Your screen is not visible. It's showing
So
black.
the frequent pattern. Really?
Yes.
Wait. Okay, my network is really bad. Is it now?
Wait,
Hello?
I guess it's coming up. Yes, now it is visible.
Okay. So where I was, yes, FE growth algorithm. So as I said, is an improvement of the a priori method and used for frequent pattern mining. It basically uses representation of the data in the form of a tree structure called as FE tree. So here, FE tree is a structure made with initial item of the data set used for mining of the most frequent items, right? So how do we generate this FE tree? So first, let's consider a transaction database. So here, each transaction has a different item. So what we do first here is that count the unique items first. So after counting the unique item, we will get a set of items with the number of occurrence. So here F 4 times, C 4 times, A3, B3, M3, P3. So now after seeing the transaction table, you will see that some of the item is missing. So why is this missing? Because of the minimum support threshold. So minimum threshold support means the number of frequencies that we will support them. So since the minimum threshold of those items that are missing does not equal to a greater three, so we are excluding from them and them free. So what we'll do now, then we will create another column for frequent items, and then we'll arrange them into descending order by taking them from. So first F A C D G I M P. So considering the count set that here, we will arrange them in the descending order. So FCAMP, and similarly all the items will be arranged on the transactions, right? So that's what we are doing here. So that's we have already discussed about that number of counts and their descending order set. So now the process of building tree. First we will start with, so basically root represents the null. Then we will go for each transaction wise. So first transaction has the items in the descending order of FCAMP. So FCAMP, the root nodes will be connected to this node, and the number of times we visited this node is 1. So each count here is shown as 1. Okay. So the second transaction items is FCABM. So FCA, then we see that after A in this path there is M but not B. So what we will do is that we will create new node for B and M. So we will connect B and M. So now the count here is increased by 1. Why? Because we have visited this node one more time. So FCBM, F, so number of count was 1, then increases 2, then C also 1, then increases by 1, that is 2, then A increases by 2, then BM. So BM is only visited once, so the count is 1. Now for the third transaction items, that is FB. So what is CS? We go to F node, then we see that in this part directly there is C, no B. So we will create another new node B for that. So now the increasing of this count. So we have visited F once again. So last time it was 2. We will increase it by 1. And for B it is only visited once. So this count is 1. So similarly we will follow this pattern creation. Then rest of the transaction. Then finally, the last tree that we got is this big whole tree here. So now how do we find the patterns? So let's take an example of item that is P. So what we do here is that we will arrange those items in a descending order. Then we will start in the minimum last order. So here P is the least that we have seen here. Wait, let me show that. So P in the descending order comes at the last. So we will take P first. So then in order to reach P, what are the paths? So we have seen that the path is FCAM and another part is CB. So we have taken FCAM and CB. So now the numeric value, which numeric value we have to give here. So numeric value of the P node we will be given to all these items. So for FCAM, the path to P includes the numeric value of T. So 2 is assigned to all this. And for path CB, the numeric value of P is 1. So 1 is assigned to this. So now within these two sets, what is the common item? So within those sets, the only common item is C. So that's why in conditional FP tree we have C, and here is 2 C2 and here is C1. So we will add both that, then this will result in C3. So the pattern will be the P itself and the CP. So this way we will generate the patterns. So the final result we will get is this entire table. So last time that we have seen that FCAM and CB. So the conditional FP tree is C3 and with the combination of P with the patterns. So similarly, all this step will be followed to find that. So here phi is there because none of this set includes the frequent one items. So F is only in 2 but not in third one. So F is not included. C is in the two of this and not in the middle one. So it is not included, and B is included in 3. But the frequent count is threshold count is not matching. So the conditional FP tree will be including phi, and this same process will be continued on. So that's all for finding patterns and generating FP tree. Thank you.
Okay, as we don't have much time, we will be ending our today's discussion here. So in this second part of our discussion, in the discussion of FP growth algorithm, the student that participate today are Sachin Datta, Joyita Deora, Kashabi Das, Fayaz Kochar, Ditiman Hajarika, Jyoti Bora, then Vivek Chetia. That's all. Thank you.